Hello guys! Hello guys! As promised, just 2 days ago, I will be able to have the discussion on colligative properties problem solving. Okay? So I will give problems now for the colligative properties. Okay, but before that, okay, I need to, make it a good sound for our microphone and connect it. Hello, hello, hello. Actually, this is not connected to the phone. This is the natural sound of the microphone. Just try to connect this one. Okay, for anything else. But it's okay, right? You can hear my voice. Okay, like that. So we are here to discover some, important formulas of colligative properties. Okay. Okay, we will just include a little bit normality. Okay. Because actually there's no normality. I will just include this. I will just add three, right? Actually there are four colligative properties.
The Bluetooth device is ready to pair.
It's been connected already, right? Hello guys. Hello. See? I'm connected now with a Bluetooth microphone. It's still the same because this is just live streaming. The sound of the microphone is just the same. It doesn't matter. Okay, hello guys. I am a singer, internal voice. If you like this live streaming, you can subscribe, comment, and like, or even share this if you think this is very useful as an academic information that you can learn a little bit, or you can learn substantial information that you can use in your everyday life, that you can use also to teach your children or to anybody else, then you can share also. Okay, this is all about chemistry. This is still under general chemistry, right? The qualitative properties. Okay, so actually there are four. We have the boiling point elevation, freezing point depression. We have the osmotic pressure or the osmosis. Okay, and we have the vapor pressure lowering. Okay, then we will add three: the molarity, and the normality. Like that, we will touch a bit for those topics also. But first, we will go to the boiling point elevation. Gosh. Okay, so I have to write this here, right? I must write only the four types of colligative properties because the other three are just additional for these colligative properties. Okay, again review what is the definition of these colligative properties. Okay, these colligative properties does not depend on the identity and the nature of the solute added to the solution. Okay, it depends on the number of particles like ions and molecules of a solute in a given solvent within the solution. So particularly, this also obeys an ideal gas solution. Okay, in these colligative properties, so most of the time we deal with aqueous solution, meaning to say the partner of our, let's say, acid or our organic acid or inorganic acids are usually water. Okay, the partner of our salts are usually water, something like that, because aqueous solution. Okay, so there are also some later parts also that have also no water also, but undergoing the neutralization reaction. You know, the reaction of acid and a base to produce salt and water. It's also okay because the reverse will be salt and water will be added to the salt, right? Like that. As long as there are charges involved, or what we call ions, the positive charge and the negative charge, like that. Okay? So those are ions, right? And then they have to interact with each other during the combination reaction or the synthesis reaction, something like that. But most of the time, aqueous solution is always water, is the partner of our solute. And here, usually the solute is also non-volatile solute also, not the volatile solute. So meaning to say it is not higher in uh, boiling point, okay? Not higher boiling point, okay? Because this is non volatile solute, okay? Like that. So, tama ba na the boiling point is not higher compared to the volatile solute? Yes, because the volatile solute will highly evaporate. So if it is highly evaporative, meaning the vapor pressure is high, right? Okay, very fluid, it will highly vaporize to the atmosphere. So it is highly evaporative. So that's volatile. Non-volatile solute, so it means it doesn't evaporate right away, right? So it has less boiling point because the boiling point is needed in order for the solutes to be vaporized, right? Okay, something like that. I guess so. Boba. Okay, never mind. Just research also for yourself about that. Okay, because that is not the main topic. Only we touched that only. Okay, but what I remember, the freezing point depression will become lower upon the addition of the non-volatile solutes. Okay, like that. For example, the accumulation of the snow. Snow is in OW. So the more snow, okay, it is there. It become a very hard solid substance, and then it become more cold. So there will be a high freezing point. Okay, the freezing point is decreasing to negative value. Sorry, negative value is the freezing point. Okay, like that. Snow process. Okay, so negative freezing point. Okay, lesser than the water, which has the freezing point of 7 degrees Celsius. Okay, like that. So meaning to say, the freezing point of water is inversely proportional to the freezing point of the solute. Something like that, right? Okay. And the boiling point elevation also will increase because of the term elevation, right? Okay, that's your clue. If it is elevation, of course, the boiling point will elevate, something like that, upon addition of the solutes. So that's your identification. So boiling point elevation, the word elevation means increase. Okay, increase, enhance, augmented, okay, intensify, what else? Another terms for that. And then depression meaning minimize, reduce, decrease, reduction, dwindling, subsides, like this. Okay, so those are the freezing point of the solution, or freezing point depression. Okay, like that. So yun siya. Colligative properties. Okay. 4 lang tamo base. Okay. Okay. Colligative properties. Okay, number 1 is boiling point elevation. Boiling point elevation. Point elevation. Elevation. Okay, and then freezing point depression. Okay. You can also have your own clue or acronym to remember faster. Okay, because this is enumeration. Okay, for example, in examination, what are the 4 colligative properties? Or you have to enumerate and list or outline your answers. Okay, like this. Okay, freezing point depression. So depression meaning uh, decrease, okay? And then if we try to say that a person, you are depressed, meaning you are not happy. The elevation meaning you are happy, and depression you are sad, something like that. If you try to equate that to general term of an individual, something like that, okay? Analogy, that's analogy, okay? We have vapor pressure lowering. Vapor pressure lowering, I don't have to explain further, because I already discussed the Raoult's law, okay? But I have to state a little bit also, okay? Vapor pressure, sorry, vapor pressure lowering like this, okay? Number 4 is osmotic pressure. Osmotic pressure. Like this. So these are the 4 colligative properties. Okay? Actually, I don't have a plan to have the live streaming today because I am very, very sleepy. I was not in good condition, but I'll try my very, very best. Okay? This one. The 4 colligative properties are boiling point elevation, freezing point depression, okay? See, vapor pressure lowering, and osmotic pressure. Now, I am very, very interested to go directly with number 4. Okay, anyway, we can choose what type of qualitative properties we will be able to start, right? I like osmotic pressure, or osmosis. Undergoing the process of reverse osmosis, especially in the purification, filtering of water substances, like that. It will be passing through the semi-permeable membrane known as the water filter. Okay, and you have to try to put that into the opening like that, and then when the water passes through that, it will filter out some of the, let's say, residues, some of the minerals, or some of the elements in solid form. Then what will come out? The pure water, not really that pure, but at least some minerals or some solids are being removed from the water. It will become, let's say, clean a little bit, okay? Because it has filtered out some solid substances, some residues, some minerals, okay? Like that. It will have going to be pure, because this deletion process is more, it is a good purification method rather compared to reverse osmosis. But still, it's okay because the minerals are being reduced also. Okay, and it will make the water clean and safer to drink. Okay, because it removes the bacteria also will be removed. Okay, suspended solids, total dissolved solids or suspended solids will be removed also. The iron, okay, it will be removed, something like that. Okay, the chlorides, okay, the parameter of water, right? In water analysis, it will be removed in this reverse osmosis procedure, or the osmotic pressure. Okay, let's go first to the osmotic pressure, or osmosis. Okay, like that. Okay, let's try an example that we have a pipeline. Let's say a pipeline that is U shape, U shape. Okay, like this. I will just illustrate. Okay, like this. Semi-permeable membrane. And here is the solution of, let's say, 3 molar sodium chloride. Okay, and here is the, let's say, the water. Okay, and this is the solution of 3M NaCl. Solution of NaCl, meaning this is aqueous solution. Okay, because this is molarity, right? Okay, aqueous solution meaning there's an addition of water, H2O. Okay, so even though the problem does not state there's an addition of water, but through the term aqueous, it's automatically added with water. Okay. Okay, so to pa, let's say like this. Okay. So here is H2O and here like this. So this is the water here. Like this. In this U-shaped tube, okay, there is water passing to this U-shaped tube, and there is what we call as a filter, okay, that is placed in the center of the U-tube, okay, U-tube, yes, U-shaped tube, of course, and then this is called what we call as a semi-permeable membrane, okay, and then we have the solution of or aqueous solution of sodium chloride, which is 3 molar, meaning 3 moles of solute over liters of solution, and our solute is the sodium chloride. Okay, so meaning to say here on the right side of the U tube, this is a mixture of sodium chloride and water already. Okay, so it is expected that the water here is less, okay, compared to the water here at the left, because at the left there is a pure water, only pure water is here, okay, like that. Now if we add pressure to the water here, I will draw arrow, pressure, applying pressure to the water, okay, so of course this is through pump, right, motor pump, because it is not a pressure through gravity, okay, that is being used here. This is a pressure through the use of let's say a motor pump to pump the water, okay, to give the pressure, something like that. Okay, the pressure is being pushed here and it will push there also the sodium chloride solution. So our new sodium chloride solution level will be up to here, for example. So high H2O, and here lower H2O, because it's already a mixture. Okay, and if we put the pressure, applied pressure from the here left, okay, and then this will go high. Okay, this is now our new level. So we can see also this is a volume 1 or volume 1, and this is volume 2, and this is now our new volume, let's say N, okay, or V new, something like that, okay, like this. Okay, so if we apply pressure, the level of sodium chloride aqueous solution will go high. So we have the volume new, okay, the new volume up after applying the pressure, and the volume initial, the volume 1 is here and the volume 2 is there. This starts originally equal, okay, but due to the pressure applied, this will not become equal anymore, okay, like that. Now since it goes up, of course our purpose is to stabilize again, to equalize again the volume of this two from the left side and the right side. Okay, how can we do that? Okay, we need to apply again pressure to go back, but a force must be going downward, also must be applied. Okay, force, you know force? Okay, like that. So I will draw another one. Okay. So it will be now like this. Our YouTube. Like this. It will go back again to volume 1, volume 2. Okay. So we'll apply the force. Okay. If you apply the force, of course, you should apply more pressure also, directly proportional with each other. Okay? Why? Take note for the formula pressure equals to force over area in this relationship. Okay? By theory. Okay? Take a look. See? Pressure is equals to force over area. If you apply force to the sodium chloride solution or aqueous solution, it will goes back to the original volume, right? To the right, something like that. And then you must apply also a higher pressure because they are directly proportional with each other. As the pressure is increased, the force also is increased. Now your volume will become lesser. So volume will be lesser. Okay? Volume lesser or decrease. Okay. Like this. So from here you will push back here with force, okay? F, okay? And high pressure also being applied. So pressure, so high pressure, okay? Directly proportional. So high pressure will be applied and the force is applying too much on the downward, and then the volume will become equal also. So it will go back to this one. It will go back to volume 1 is equals to volume 2. Okay? So equalize volume already. So as you applied force, of course, the pressure will increase because it is directly proportional with each other through the equation pressure is equals to force over area. Or even though without that equation, if you apply force, normally there's a lot of pressure to be exerted. Okay? Normally, by an individual, by a machine or whatever. Right? And of course, the volume will decrease. Of course, whatever media, it could be a gas, a liquid media, solid media, liquid media, liquid media, solid media, gaseous media, it will decrease, right? The volume will decrease, and then the volume will equalize the volume here too. The volume 2 equals to volume 1. Something. If it is equalized already, okay, now this is an ideal solution, ideal gas solution. Okay. So what is our formula for ideal gas solution? Okay. Okay, so equal na siya ha, tanawa. Dibalik siya. Okay, dibalik siya equal. Okay. So 3 molar in ACl. And this is here water. Okay. So like this. So it goes back to the volume in the initial stage. So our volume now is level. So we try to level the volume. Now we can apply now the ideal gas solution for osmotic pressure. Okay. So again, we connect that to the PV and RT. Okay. Like that, using the principle of PV and RT because we are applying here the ideal gas solution of the sodium chloride and the water. Okay. So, obeying also the ideal gas equation. So, PV in RT is 1. Okay. This is our ideal gas equation or our general gas equation, PV in RT. So, we equalize now our volume by pushing that with force and applying pressure, and the volume in the other side, we equalize the other volume here. So, our volume is already equalized or in equilibrium. So what will happen if our volume, if ever, sorry, my tongue was plural again, okay, is being equalized, it's in a steady state, okay, steady state phenomena. Okay, so volume 1 equals to volume 2. Now we let this volume to be equal. That means we assume the volume that remains constant. Now divide this equation PV and RT with V from both sides. PV divided by V and RT divided by V, because this we assume that to be equal or remain constant in this principle. Okay, like that. So divided by V, cancel. So pressure is equal to, okay, N over V RT. See? Pressure is equals to nRT. Or N over V times RT. Okay. Right? Okay. So if this is now the equation, what will happen? Okay, remember this N is the number of moles and the V is the letters also. This is the molarity. Okay? Through applying the PV and RT, this will become the molarity. So we will insert the molarity. Okay? So pressure. See, if you will understand, you will enjoy, because you really understand. Even though the problem will become complicated, if you understand what's happening, and you can derive the equation, something that you can understand, and then you can still answer the problem, especially for physical and chemical sciences, or physical and chemical separation processes. Okay, more on concepts and theories. Secondary, the problem solving will just be secondary. As long as you understand the concepts, theories, principles, and laws, then you'll be applying that to the problem solving. Even though how difficult is that, you can still manage to solve those difficult problems. Though there are some times or you will feel difficulty, but you can still answer that one. Okay? If you have just given enough time to answer that one. What will happen in an examination, especially the PRC engineer's board examination, is that it was time pressured. Of course, normally the individual will be panic. Okay, normally the individual will be panic. Okay, and then the person will be will be afraid, confused, doubt, because it is time pressure. So what you have in your minds, so many formulas, and you've studied a lot, there's a tendency that it will be evaporated. All the formulas and equations that you had memorized, that accumulated and retained in your brain, will be lost, because you are now focusing in the actual environment, on your seatmates, like that, and then there's a proctor and there's a time pressure. Even though you know that it's suddenly lost all, so you should focus and concentrate to what you had studied and just relax a bit. Okay, just take your time, something like that. Anyway, you can still solve that one. Okay, never mind the pressure. There's still a pressure there. Okay, pressure is applied to any situation, right? Okay, so we have now the P, pressure is equals to the number of moles N over V, which is the volume, and the R will be our universal gas constant, or the ideal gas constant, times T, capital T. Okay guys, in science, okay, in general science or pure science, whether it is a physical chemistry, whether it is a general chemistry, or would it be, let us say, clinical chemistry, nuclear chemistry, environmental chemistry. There's a lot of chemistry. Organic chemistry, quantitative chemistry, qualitative chemistry, biochemistry. How many chemistry we have in our universe? A lot of branches of chemistry. So this chemistry is the contributes the more parts of pure science compared to physics and biology. Okay, there's so many areas for chemistry compared to the biology and the physics and the earth science and the astronomy. Okay, meaning the planetary science. You remember that one? We have the planets, the moon, the suns. It's also pure science, what we call as the astronomy, or the planetary science. And you have also the science talking about the soil, the earth's crust, like that. That is earth science. Or we have also the geology, that is also pure science. geology, the rocks, the soil. That's why the mining comes in. Mining also is a branch of uh, science that focus on the geological aspects, okay, on the Earth's crust, something like that, okay. So there's a lot to cover for the pure sciences, okay. So in chemistry, so many parts. So you will be, some or all of us, I think so, found difficulty in chemistry, okay. Not all, but majority found difficulty of chemistry. There's so much branches, okay. And the biology will combine to chemistry. It's now biochemistry, okay. And then the engineering combined with biology, combined with chemistry. What do you call that one? That is biochemical engineering. See, again, the engineering talking about technology combined with chemistry, combined with biology, that is biochemical engineering. Okay? And then biology combined with chemistry, that is biochemistry. Okay? If you talk about the water, the air, okay, the land, talking about the chemistry of water, air, land, okay, that is environmental chemistry that focuses on the pollution, okay, the waste pollution, the water pollution, the air pollution, the land pollution. It's still chemistry under environmental chemistry, okay, and we need to detect the different contaminants found in the atmosphere by using the device, something like that, in the water, also using a device to detect also what are the contaminants in the sea level so that our fish will not be killed, something like that. So we need to maintain the parameters of water, whether it is rainwater, seawater, or the bottled water that we drink every day. So that is under environmental chemistry. Okay, so the environmental chemistry is very interesting because environment is our habitat. You know habitat? Environment is our habitat in which we live in the environment. And the environment is within the ecosystem. Okay? In the ecosystem, there is an interaction between the individual, the human being, the animals, and the plants. That is called the ecosystem. System meaning plants, animals, okay, microorganisms, and the people are reacting with each other through the cycle. Okay? Remember the cycle? Before, commensalism, parasitism, something like that. Okay, so many cycle in the biology. So that's part also of environmental chemistry. So we live in our environment as our habitat, and there we have the ecosystem, our relationship to animals, plants, and microorganisms. But both of ecosystem and environment are present in the earth, within the earth, our mother earth, or the planet Earth. So planet Earth is under the study of planetary science also. Okay? So if you connect that, the science is a very broad subject. It will never end. Okay? Like that. I think it is more broad than mathematics. Okay? It is broad than mathematics because the world we live is all about science. Okay? It's not all about mathematics, it's all about science. Even though without mathematics we can still live. Okay, but without science we cannot live. That's the point of philosophy. Again, without science we cannot survive in this world. But even without mathematics, I can still live. Okay, I can still live without addition and subtraction, and and polynomial or whatever. But I cannot live without oxygen and nitrogen, which is under the environmental chemistry, right? So that's why the most important subject is science. Okay? Even though you have no education, you can still be alive if there is science, because there is water, air, and food. Okay? You have no education at all. Let's say you don't have education, you have no grade at all, you don't go to school, but you survive because there's science. Okay? They cannot, they can still survive without mathematics. They can still survive without English. They can still survive without social sciences. They can still survive without economics. They can still survive without probability and statistics and everything. But they cannot survive without science. Okay? That's the point of philosophy why I love science. Okay? That's my favorite subject. Okay? Like that. And combined with English. Because I love English so that I can interpret in science subject, something like that. Okay? So that's more broad. Okay, it will never end. I think after this century, there's another, let's say, law, theories discovered to certain new generation. Students, okay, they have another law, and then the law of Isaac Newton will be phased out. Okay, like that, the law of Archimedes principle, you know that one, like that, and Dalton atomic theory, the Arrhenius theory of acidity and basicity will be eliminated. The Le Chatelier principle also, okay, the shifting of the chemical reaction, if applying a stretch to a chemical reaction, maybe there's another law and principle will be discovered by the new generation students after 200 years, because the science is a continuous cycle. Okay, there are still a lot of new discoveries that will come. For example, if the moon of Earth, only one, maybe after 100 years it will become two. We don't know, because the science is through evolution. You know, evolution, we cannot predict what's going on. Okay, maybe in the Mars, the people will be transferred there because the Mars have no water, have no air, so we can survive now there. So that's the power of science. Okay, it's continuous evolution. We cannot predict, and every day there's a discovery. Okay, like that. That's why very important to have an observation, an inference, hypothesis, gathering of data. Okay, so that we can have our scientific theory and scientific law. So these are all the scientific method in a scientific research. So these steps in a scientific research as our scientific method is used by the scientists to have a scientific laws and equations, something like that. And through that, they can create books in science, something like that. Okay? So go back to PV and RT, my gosh. So too much connection. Okay? R, as we can remember, as I told you before, don't forget, that is 0.08206 liter atmosphere per mole Kelvin. Okay, this is our R. Actually, you can solve so many R. The technique is, for example, in an examination, you forgot what's the value of R. I have the kilopascal, and I cannot insert that there, and then my mind will be in trouble, too much conversion. You should convert directly the R. Use the PV and RT also by using the STP, standard temperature and pressure. Okay, at pressure 0 degrees Celsius, at pressure 1 atmosphere and temperature 0 degrees Celsius, that's standard, right? Okay, you should remember that one. And then there will be the ideal gas. 1 mole of an ideal gas will occupy 22.414 liter in a space in that STP. Then you can have R without memorizing that one. You can only plug in, substitute to the R, PV and RT. Okay, because R is in the equation of PV and RT. If you forget the value of R, and if you don't know the value of R, just substitute it, derive from there, something like that. But most of the students are memorizing that one because it's easy to plug in or to substitute in the equation. Okay, rather than going to the handbook or research or whatever, it will consume your time. It's scanning the books, something, and scanning the books, and you will only memorize the 0.08026 like that. Okay, not very so many digits, only 0.0820, so easy to memorize. Okay. 0.08206. Some textbook in chemistry are rounded off this as 0.0821. But here I'm just using the 0.08206 liter atmosphere. Okay. Mole Kelvin. Okay, like this. Okay. Kelvin has no degrees, You remember? Kelvin has no degrees. Only the Rankine, the Celsius, and the Fahrenheit. And there are only four formulas of temperature in science. There's no other. Okay, the Rankine is equals to 1.8 times Kelvin. Okay, the Kelvin is equals to degrees Celsius plus 273. The Fahrenheit is equals to 9 over 5 times degrees Celsius plus 32. And you have the degrees Celsius equals to, okay, 5 over 9 times close and open parenthesis degrees Fahrenheit minus 32. So if there are certain temperatures, then you have to convert that one in order to agree the units in the ideal gas equation or in the osmotic pressure or whatever qualitative properties formulas you'll be able to substitute that one. Okay, like this. Okay, going back to the P is equals to N over V RT. Okay, like that. We know that N over V, capital V always ha. Okay, and the small letter n is the number moles always. Take that in your mind. In chemistry, the small letter n is always the number of moles. Don't confuse that, okay? And the small letter x is always the mole fraction, okay? Like capital V is the volume. So sometimes you have to figure out what are those symbols for easy solving the problem also. For easy identification and for easy recalling the variable symbol, something like that. Okay, N is the number of moles. Okay, and then V is the letters of solution or letters. Okay, like this. Some textbook using LI, but you can also use capital L only. Do not be confused. Only, hypothetical, only representing, letters. Doesn't matter. Okay? This one. N over B, N stands for the moles of solid over V is the letter. And this is the equation for the molarity, capital M. So if this is the equation of the molarity, then we will substitute to the PB in RT. Again, going back. So it will now become 2 P is equals to capital M times RT in the osmotic pressure formula. Okay, P is equals to capital M. What we did is the derivation of equation. Okay, in case you will forget or you will forget the formula, you can still have the formula in your mind. Okay, this one. Actually, this is now our standard formula for osmotic pressure or osmosis pressure applicable in the reverse osmosis. For example, in the desalination of water, water from the sea, it will become a pure water due to this process of reverse osmosis. So this pressure will be able to use. The principle is this, okay? By applying the pressure, osmotic pressure. But then, as you can notice, the capital P will confuse to the original PV and RT equation or P and VRT, right? In order to understand well, we should represent that as pi. Okay, again, don't be confused to the algebra or mathematics. The pi there is 3.1416. Okay, circumference is equal to 2 pi r, in which r is the radius. Okay, like that. Like pi is 3.1416. Okay, 2 times radius is equal to diameter. Area is equal to pi d squared over 4. Blah blah blah, so and so. Okay, circumference equals to 2 pi r, something like that. Yes, it is correct. 2 pi r. Okay, like that. So we will represent this as a pi also. Pi MRT. Or you can create your own. No, it doesn't matter. Okay. But this is the purpose of uniformity. Okay. Pi is equals to MRT. Okay, this is now our formula. Now, you have to account the temperature in Kelvin. Okay. Now we will substitute the units in order to agree, because your memorization sometimes will fail, right? Of the formula. If you substitute the units, you can really prove what's left is pressure, what's left is volume, what's left is the universal gas constant, what's left is the temperature in Kelvin. Okay? So that will prove your formula is correct, rather than you trust it 100% to your memory. Maybe you forget something in the formula in your mind. So you have to prove also the units, okay? So N moles of solute. Okay, so moles per liter. Okay, R, liter atmosphere, mole Kelvin. Okay, so that we can understand. Okay, liter cancel, mole cancel, and our temperature is in Kelvin. Kelvin cancel. So our pressure is atmosphere. See, our osmotic pressure is in atmosphere. If we plug in, if we substitute each unit of the variables involved in this equation for osmotic pressure. So we can really say that osmotic pressure came from the original ideal gas law or the ideal gas equation. It derives there because of the principle. We are using the ideal gas solution behavior. Okay, now if your solution in that certain pipeline, in a YouTube or whatever, okay, if that is not an ideal gas solution, this principle will not be applied also. Because we have also the real gas, right? The real gas obeys the van der Waals equation. Okay, if you can remember. So you can use the van der Waals if it is a real gas, meaning that is not an ideal gas, of course. Okay, the opposite of ideal gas is a non-ideal gas, or what we call as a real gas. So therefore, I conclude that ideal gas is a non-real gas. Nakuha mo? The ideal gas, okay, real gas is the opposite of ideal gas. So automatically, this real gas is a non-ideal gas. Okay? So therefore, if this real gas is a non-ideal gas, okay, therefore ideal gas is a non-real gas. Okay? You get the point? Like that. Sometimes it will be stated also in the problem, a real gas, blah, 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 so and so, monoatomic gases, diatomic gases, triatomic gases, okay, will react to blah, 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 so and so. It doesn't mention formula at all. Okay, sometimes really in a problem, it will not mention chemical formula at all. But then, suddenly you can solve anything because there's a STP, you know, at standard temperature and pressure. It will just say like this, an ideal gas, blah, 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 will behave like this. And there's no other, sometimes there's no data at all, really, no data. And then you will ask for something because there's an STP, standard temperature and pressure, room temperature, because at room temperature, let's say 20 degrees Celsius, the density of water will become 1 grams per ml, like that. And you can also interpolate that in a graph, okay, to have a new density with corresponding another temperature, interpolate, okay, you can remember the interpolate, or you can use also the ratio and proportion if you have the same properties, okay, being studied or being compared or being analyzed. Okay, you cannot do the ratio and proportion if it does not have the same properties, conditions, situations. Okay, you cannot do that. The best thing to do is you do the interpolation, okay, and make a graph, something like the x and y axis, blah blah blah, so and so, and plotting the points, and you can get a very linear graph, a continuous graph, okay, and then it's very, you know, it's very systematic, and you can do it a long time. So this is our formula for osmotic pressure, osmosis pressure as one types of colligative properties. My gosh. Okay, now we're going back to now to the boiling point elevation. Actually, there are certain textbook also that uses vapor pressure depression. See, because depression and lowering is just the same in term. Do not be afraid. Okay, because the word is already changed to vapor pressure depression. You think that it's still under freezing point depression. No, it's not. It's still vapor pressure depression because depression and lowering is just the same meaning. Okay? Lowering, decreasing, reduction, and depressing or depression. Okay? Sometimes English will matter also. Synonymous terms. Okay? Like that. Okay. Let's do the example first so that we can have the problem. Okay, my gosh. Last night I gathered some problems Okay? And I did not solve yet in order to make it more challenging. Charot! Okay, makalingaw man siya. Fairness. So, nindot kaya ang question ani niya. Grabe. Kasi man to, eh? Fair. Hello guys, are you still there? Okay, you are still there. Hala. Noah. Ang atong example karon, our example will be like this. Okay, I will just write this letter. 9 gram of non-electrolyte solute, oh my gosh, nakakatakot, was dissolved. Kabahan ka na. From the word alone ng electrolyte, kabahan ka na. Fairness. 9 gram of non-electrolyte solute was dissolved in enough water to produce a 500 ml solution. So take note, there's already a volume, which is 500 ml. Okay, and water, so meaning aqueous solution. So first, ideal gas solution is applicable. So the theories of gas, ideal gas solution will be applicable. Okay, the osmotic pressure is to be 1871.1 torr. It's not atmosphere, okay, at 300 Kelvin. What is the molecular weight? See, ang layo ng hinanap, di ba? What is the molecular weight of the solute? So it looks like this is a combination of a quantitative chemistry and a qualitative chemistry, right? You need to determine what type of compound is this, okay? And then you need to know also the amount of this solute that is being added. And what compound is this? Well, yeah. Too difficult really, because if you will not think this up, okay, we'll just try using the formula. Okay, just solve it also so that it will become enjoyable, okay? Anyway, you can, I think it's open handbook, okay? If you have a handbook, then you can open handbook, right? Okay. Muna siya. Non-electrolytes kaayo, di ba? Fairness. Hello guys, I think this will take a long time for this live stream because we still have other 3 colligative properties. Okay? That's why, now I know, that's why the instructors will take longer time to discuss it, right? And then it will reach to how many months, this, prelim, midterm, and finals, because it's really broad, so many topics like this. And now I understand, it's not easy pala siya. We have so many lessons to cover, and then it will eaten up your time. Okay, something like that. And that's why sometimes they will make it fast in discussion because they try to reach the target or the deadline of their lesson plan, something like that. That this week we will finish this coverage for colligative property like this. For the next month, we will finish the redox equation in acidic and basic equation. Okay, in acidic and basic solution, and the next month will be the computation of the oxidation state and the oxidation number, like that. And the next month we'll be able to have the chemical equilibria, something like that, phase equilibria, the dissociation of gases. You remember that one, the KSP, the solubility product constant, like this. If you dissociate the sodium chloride into sodium positive plus chloride negative, your KSP will be the concentration of sodium positive plus chloride negative. O, diba? Oh, I still remember that is solubility product constant. Okay, because I memorized that before when I was in college and it's still written in my brain. After 20 years. Oh my gosh. If you memorize and you understand it, it will really retain to your brain. But there's still a little bit of confusion, but you can manage it by adjusting it when you write the formula, and then like this, that's what I discussed earlier, you have to put the units, and then you can prove that the formula you'll memorize is correct, something like that. But my point is, if you memorize that really, it can really retain, that's my point, okay? Like that. Okay? So many. And the problem here also, because it will be rumbled. Rumbled mixed. And sometimes really, this is true. when you face the examination also, sometimes you cannot identify also because it's really rumble, mixed. For example, the colligative properties are being mixed with the other sciences like this. How can I do this? And then the ideal gas is mixed with the thermodynamics like this, and then there's also ideal behavior gases for thermodynamics, and there's energy. And then I cannot explain, but it will be confusing all throughout the examination because it is not by topic. Okay, unlike in the you are a normal student or average student during the session of your instruction. It is unit lesson by lesson, but in the examination it will be mixed all throughout, so many coverage, and then sometimes even though that is very simple, you cannot think properly, and you think it is difficult. Okay, like that. For example, you will convert normality to molarity, something like that, and you will be given molarity, something like that. For example, 0.35 molar of sodium chloride solution. What is the normality? Diba, you will solve that a lot because using the formula of normality, which is, as far as I can remember, the equivalent weight or of solute per liter solution. I think so. Okay, just also go over it. Okay, and then it's very difficult to solve for the equivalent weight. So many blah blah blah, so many so and so. You have to get the mass, you have to get the molecular. But what if you will try only to multiply that with the what? The ions. Okay, the ions of the sodium chloride that it will dissociate. It's just the same. So 0.35 times how many ions it will dissociate. So you will plus the charge of the hydrogen from the chlorine, so it will become 2. So that is our I. Okay, so I times the molarity, it will become the normality. So no too much solving. We can get easily the value of normality. So it will take time. That's why. Okay. And that's I discovered now. Before when I was in Canada, I did not discover that one. Okay? Because the teachers will always taught us to use the formula. They don't teach us to go directly the most simple one. Okay? Because of course, if you use the simple one, the student also cannot understand very well. So that's why they use the formula in a systematic method so that you can understand where that came from, like that, the variables came from that original equation. Okay, like that, okay? But now, it's gonna be like this. The normality is just equal to the molarity times the I. The I is the Van Hoff factor. You know Van Hoff factor, for example, HCl will dissociate into H plus chloride negative. So negative plus positive, supposedly it equals to 0 for the neutralization reaction, right? Charges with different signs will react to produce 0. To neutralize with each other, but in Van Hoff factor, the charge, the signs are not used. It's still the same. So 1 plus 1 is equals to 2. 1 charge hydrogen positive plus 1 charge of negative plus the chlorides, then 1 plus 1 is equals to 2. So the signs are irrelevant for the Van Hoff factor. Okay, you will just add directly. Or you can state it differently if it will react now in the equation. You can use the coefficient and the number of moles. Okay? For example, H plus, okay, chloride gas. Okay, the chloride gas have 2, right? 2 in the subscript. So 2, and the hydrogen has no subscript. So that is like that. So it will be 2. Okay, like that for the chlorides and 1 plus hydrogen. Now we are not interested for the chlorides because we are only the acidity H, that is 1, something like that. Okay, it's very clear. Okay, like that. So you will not be confused about that. Okay, like that. Sodium sulfate, blah blah blah, so and so. How many I for that? We plus ano mo siya, whatever. Okay. So that's a shortcut method of getting the value of I. Why I mentioned the value of I, the Van Hoff factor? Because I, Van Hoff factor, is directly proportional to the boiling point of the solution. the greater the value of factor during the dissociation of a certain aqueous solution. Charot. Okay, the boiling point will also be increased. Okay, and the boiling point is inversely proportional to the vapor pressure of the solution. I'm talking for the solution, huh? I'm not talking for the solute. Okay, the vapor of solution will be lowered. That's why we have vapor pressure lowering upon the introduction of the non-volatile solute. Okay, it's like just the freezing point depression. Okay, it will just become lower. We add the non-volatile solute. Okay, the vapor pressure will decrease, something like that. Vapor pressure lowering na, di ba? Okay? Ako ng ship swap, in fairness. Okay? Oh my gosh! So, let's continue tomorrow, guys, for the colligative properties. Okay? It will take time too much. A 9 gram of non-electrolyte. So what do you mean by non-electrolyte? Meaning, if it will dissociate or decompose, it will not produce electrolytes. Okay? Or salts. It will not produce salts. Like that. Electrolytes meaning there is a negative charge. Okay? Electrolytes, there is a negative charge. Why? From the word electrons. Okay? Electrolytes, from the word electrons. Electrons is a negative charge. Okay? So that is electrolytes. So the salts has negative due to the chlorides, to the sulfates, to the phosphates. So those are salts. So this non-electrolytes is not like that. Okay? So you should also detect the root word. Okay? I will write dissolve in enough water. When the water came out, I will be happy because that is not difficult too much. Because I'm afraid if mixed with other, organic liquid, for example, toluene, benzene, chloroform, dichloroethane, what else? Formaldehyde, like that. Okay? Too much problem. Enough water. Because that is also solution. Because the solution is not only mean there's a solute, okay? That could also mean solvent is still a solution. We consider the other solvent as the solute because the other solvent will be soluble to the other solvent. Okay? So it's a wrong concept to say that a solution should always contain the compound solid or whatever. Okay? It's always liquid. No, it's not. Okay? It's always solid or solute. It's not. Because sometimes the liquid and gas can be act as a solute plus the solvent in the solution. That is liquid solution, liquid gas solution, right? So it's not all the time solute and liquid solution. Okay? Like that. And don't be afraid for that. You will find a solute and there's no solute because your identification of solute is only solid. No, it's not. It could either be liquid, organic liquid, inorganic gas, blah blah blah, so and so, whatever. Okay? Inert gas. What is inert gas? Ano ba naman? Enough water to produce. So inert gases are those gases are highly stable. It will never react anymore because they are stable. Okay? So they will react anymore because they will not react anymore because they are stable. So they are non-reactive. That is inert gas. Examples are krypton, neon, xenon, argon, like that. That's why argon and, you know, what else? Argon are used, you know, in the confined space as our cleaning agent, something like that. Because argon will not react to oxygen. Okay, so oxygen will not be displaced during inside a confined space. Though, if it will displace the oxygen, so the people cannot breathe anymore because the oxygen are being lost. So that's why we will use the inert gas. That's the rule. Why we use, there are a lot of gases, then why we choose especially the argon, blah blah blah, so and so. All inert will be used, okay, to produce a 500 ml 500 ml solution. The osmotic pressure, oh my gosh. I will finish this one after Kalash. Okay? The osmotic pressure is to be 1871.1 torr, right? At 300 Kelvin. In thermodynamics also, the temperature is very important. Why? Because thermo, meaning thermal, temperature is already a factor in the subject alone by the word thermo, meaning heat. There's application of temperature, so that's why the coverage mostly dealing with temperatures. Remember that, okay? Q is equal to mCp dt, the specific heat capacity of water, the specific heat of water, okay? Because the specific heat is not the same as specific heat capacity. Remember that one, okay? Of water, and then like that, but delta change in temperature, final, initial, like that. Always having temperature in your computation in the thermodynamics, because the word thermo alone could signify that it involves always the application of temperature. And thermodynamics is under science also. Specific. What is the molecular weight? My gosh, kaloka itong molecular weight of, but in qualitative chemistry, right? A quantitative chemistry, you will determine the, you know, the amount, the unknown with the amount, something like that. Am I correct? Because qualitative, you need to determine the what kind of compound or element that you will be able to determine in your analysis. And in quantitative, you have to determine the amount or the how much present in the solution. Like that, you will be given an unknown solution, and you will be able to determine the amount of that solution. Okay, the amount of that element, each element comprises to that particular solution. That is quantitative, right? But the qualitative, we need to determine what elements are being present in that compound. And we determine that we are giving an unknown liquid or unknown solution, and we determine that is going to be nitric acid, blah, 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 so and so. Okay? It's just the reverse with each other. And then more on laboratory, you know, laboratory analysis, and you have to prove that one, okay? And through gravimetric analysis, ganon, titration, okay, in the laboratory, in the, you know, chemistry, I think so, weight of the solute. And what compound? Gosh. And now, for this question alone, you can easily think, what are those compounds that are non-electrolytes? Think na ka, okay? You should start to think about that. So what are those? For example, it is a protein, enzyme, okay, carbohydrates, fatty acids, okay, carboxylic acids, okay, like that. or it could be an amino or amines, okay, in organic chemistry. You'll think of a certain, compounds or substance that has the molecular weight to be the non-electrolytes, okay? But sure, it is no longer an acid and a base because a base and acid has charges, okay? So eliminated automatically the electrolytes. Of course, that's electrolyte, that is non-electrolyte, yeah? What compound is this? Okay. Like this. I will give you 1 minute to, write the problem and solve it by yourself also. Okay? Like that. Okay. Oh my gosh. So let's have now the formula of osmotic pressure. Pi. So the first thing to do is to present or to put in our paper or initiative paper the given, given the data mentioned in the problem. And then the second will be the required, what is being asked on that particular problem. The third, we need to analyze, evaluate what are the particular and appropriate equations and formulas that will be applied to those kind of problems in that kind of required. Okay, you have to adapt now. If it is appropriate to use this, blah blah. That's the time you need to analyze the basic concepts and basic theories behind. Okay, because you will not also use immediately because you have the formulas. You have to analyze also what is the applicability. What is the applicability and the limitation of that formula that you will be able to use. Maybe it is not applicable for that problem, then do not force it. Unless there's no other choice, you will force it, and then you need to connect and to derive another formula by those basic formulas also. Okay, like that. Okay. So pi is equals to mRT, osmotic pressure, right? Since this is M, okay, then the problem also will give molality. Of course, you have to convert molality first to molarity. That's only a trick, huh? Like that situation is only a trick. And sometimes the problem also will state like this: a 9-gram molecule has a solubility like that. Okay, and then find the osmotic pressure. And since we know the meaning of solubility is just only a concentration, so automatically it could be the molarity. It's still present in the formula of osmotic pressure, right? Like that. Do not just depend on the word by word that it's gonna be like the problem like that, and then there's a lot of possibility. They will change the terms and the words sometimes. Okay, like that. And sometimes they will not use the small letter M, molality. They will use the unit itself. Okay? Like that. And you have to be alert, something like that. But again and again, things like that is not really, in the actual examination, you will be, pressurized, that's why. Or pressured. Not pressurized, pressured. Oh my gosh. Okay. Pi is equals to mRT. MRT is not Manila Railway Transit, ha? The MRT is molarity, okay, times the universal gas constant or the ideal gas constant times the temperature in Kelvin. Okay, so we have now the osmotic pressure, which is 1871.12. And then you have to think also, during conversion, which is more easy to convert, huh? Okay? So that it will not take or consume too much time. Go to the conversion that it will be easier to convert directly without going to certain other things. And it will also use up your time, something like that. Okay, M is equals to number of moles times the liter of solution, something like that. Okay, and our volume is 500 ml. See? How about stating that in liter so that the student will substitute immediately? Okay, their purpose is to let the student think like that. That's why we need to convert first before plugging and substituting to the original formula. Because if you try to examine the formula, the liter is the volume, right? Why the problem is giving ml? Okay, so what's the purpose of the author of that problem? Meaning to say, he let the student think that he understand the conversion factor from milliliters to liter, from liter to the milliliter, something like that. Okay? So, solution. Okay, take note this also as a K indicator. If it is a solution, you can substitute that directly to the liters in the molarity. But if it is not a solution, for example, 500 ml of water, you would still have the other volume for the solute. Volume plus solute plus volume of the water, which is our solvent, is equal to the volume of the solution. Okay, now you will be afraid also. There is also a volume of water, okay, but you don't have the volume of solute. Okay, how can you find it? So, don't forget the density. Okay, the density is equal to mass over volume. If the density is given the problem, then you can get the volume, right? And then, how about the mass? You can get the mass because there's a molecular weight. Okay, 1 mole of a certain compound, okay, will occupy to this weight, molar mass. So the grams is also there, like that, things like that, stuffs like that. Okay, do not be afraid. Okay, but it's normal to be afraid. Okay, I guess. Okay, R. Since in the osmotic pressure, we will focus now on the atmosphere because in the osmotic pressure, the standard pressure is atmospheric shock. Okay, like that. Okay, so we will use the atmosphere. Okay, R is equals to, the R here is not mentioned, right? So it is understood in the problem that we already memorized the R. Or we can derive that through the PV and RT equation. R is equals to 0.08206 liter atmosphere, okay, mole Kelvin. Okay, so we have now the R, which is our constant, the universal gas constant. Okay, like this. Sometimes also the problem will say R only, ha? And then sometimes the question will say, what is the universal gas constant? Like that. And then you don't know the definition of capital R. So that's will be all trouble also. That's why the power of memorization is very important. Okay, because they can put everything what they want, okay, in the problem. Okay, sometimes you will put only R is equals to something like that. Okay, and then calculate the value of R. Okay, and you don't state calculate the gas constant. The problem will always sometimes state calculate the value of R. See, since it is understood that the value of R is the ideal gas constant, then if you didn't memorize the term for that, no problem also. Okay, like that. So temperature is in Kelvin. Our temperature here is already 300 Kelvin, thanks to God. See? Already in Kelvin, 300 Kelvin. Okay, thank you, Lord. Okay. Okay, we will plug in. Now, we cannot plug immediately the torr, ha? The torr unit of pressure, because we are referring to the atmosphere in osmotic pressure as our basis palagi siya. Okay, so 1 atmosphere is equals to 760 torr, basic conversion factor, and we can have now the atmosphere. Okay, so 1,187.1 torr is equals to 1 torr 7. Okay, 1 atmosphere, sorry, is equals to 760 torr. Pahamak. Okay. Sometimes it will ask also the, what is the height, blah blah blah. Why? Because there is a unit of mmHg in the pressure also, and mm is the milliliter. Okay, but thanks to God, this is not a mmHg unit. Okay, like that. So 1871.1. Calculator. I use the calculator. Okay. So 1871.1 divided by 760. 2.46 atmosphere. Okay. So substitute na. Ganon. Substitute. Hello. So pi is equals to 2.46 atmosphere, and then n over volume, which is, now we have the volume of 500 ml. We will convert this to liter because our formula for the molarity, capital M, is in liter and shot, right? And this is already a solution, no problem. So 0.5. Move to the left. Okay. Because 1,000, 1 liter is equal to 1,000 milliliters. The milliliters is 10 to the negative 3 in the prefixes of algebra, right? Milli. Okay. So 0.5 liter. Okay, substitute that one here. I have the 0.5 liter. May ganon. Okay. And then our R is 0.0826. 06 kalagort mol Kelvin, and then times the Kelvin, which is platoon temperature. We have ganon. We have 300 Kelvin. Yes, 300 Kelvin. So muna na siya. We simply substitute the values, and what remains is the number of moles. Okay? Like this. This is the number of moles, meaning our unit is MOL, right? Of course. Okay, we cancel the sorry. We cancel the unit one by one. ATM, automatic tiller machine, ATM atmosphere. Sorry. Joking. Letter, Kelvin, and what will left is the number of moles. So what is our number of moles now? Gosh. Crisscross mathematics, cross multiplication, or you can have also directly dividing it by PEMDAS. You know PEMDAS? First, parenthesis and bracket. Next is the exponent or the roots or the powers or the orders, and then the next will be the multiplication. The next will be the division after the addition, etc. That's PEMDAS. Okay, or it could be BOMDAS. B is bracket, the same as parenthesis. Or it could be BIDMAS, BIMDAS, because E is the exponent and I is the indices. Okay. Roots, exponents, square roots, all are example of indices, okay, or order or roots. Those terms can be changed interchangeably. That's why our acronym for mathematics and algebra change also, differ in some country. For example, Canada, they use the bed mass. In USA, they use the bead mass. Instead of E as in eagle, they use the I. So bracket, indices, okay, multiplication, division, addition, subtraction, so bed mass, something like that. Okay, na PEMDAS is the general, the worldwide, like this. Parentheses, exponent, multiplication, division, addition, subtraction. That is the order of mathematical operations. Okay, so if you will use first, for example, it will be rumbled. So if you will not follow this technique, you will be wrong. Okay? because you use because normally we solve from left to right, right, in mathematics, and in some cases it doesn't hold true to that. For example, if the multiplication is at the last, you will go to the last before going to the left. Okay? Because if you add that one, it will not yield the same answer. Okay? Like that. So it's useful. PEMDAS, PEMDAS, BEMDAS, BEMDAS, like this, blah, 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 so on, so, and BOMDAS. Or BUDMAS, the same. Okay. Because division and multiplication can also be used interchangeably in that particular method of operation also. Okay? Like that. But start with a bracket or parenthesis. Okay? And then exponent, blah, 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 so on, so. Okay? That's basic in algebra. Okay? Number of moles, like this. Gosh, 0.5 times 2.46 is equals to, divided by 0.08206. We have, our number of moles is 14.9. Okay? Okay, since we have the 14.9 moles, okay, what is the molecular weight? Okay, there's a relation for that here. See in our problem, see? 9 grams. So that's the time we will use this 9 grams. This is the mass. Right? See? So if you divide this one, this is gonna be the molecular weight. Right? Am I correct? Let's say, sabi ko nga sa inyo, I'm afraid. 9 divided by 4.9 divided by 14.9. Okay, like that. Okay? So our answer will be, we will convert this one like this. Okay, in this situation, for example, let's say gram divided by the non-electrolytes. We cannot divide because we don't know that electrolytes is the problem really. Okay, so we automatically say that grams per mole, right? It's the unit of the units of the molecular weight, right? And then if you divide 9 divided by 14.9, okay, 0.08206 divided by 0.08206 divided by 0.5 is equals to like this, okay? And 2.46 divided by 0.1642 is equals to, oh my gosh, 0.0. If there's a point, too much problem, huh? Too much decimal places, okay? That's the problem. See, too much decimal places, that's why. Okay, and then 2.46 divided by 0.164, 15 or 14.9 moles. Yes. Then if you divide the grams here, which is 9 grams only, we divide 14.9, it's very less. So you will say in your computation that it is not possible. The molecular weight is only point something, like that. Okay? 9 divided by 14.9 is equals to, see, 0.60 only. So is there a molecular weight which is 0.60? So we have to go back. Okay? As I told you, this is on the spot problem solving. Okay? Good if I will practice that. If I will practice first, then before discussing to you, it must be perfect. But since this is on the spot solving, it is expected that we can commit errors, right? So let's go back to the problem. Okay. Here we go. Maybe only in the, in the multiplication, wherever. Let's check our formula. That one. Yes. Pi. 171.14. Okay? I-divide mo siya of 760. So, 1871.1 divided by 60. 1871.1 divided by 60. 760. The calculator sometimes wrong. 1871 point. See? 1 divided by 760. Sorry guys, I only review. Okay? There's something wrong with plugging in the original equation. So that's 2.46. 2.46. So molarity, the number of moles will be N over the volume, which is 500 ml. Oh, dito tayo nagkamali kasi po dito tayo we are in error because what's in my mind is the vapor pressure lowering. Okay, see, if you review one by one like this, we can that's why in examination you have also to give time to review. Okay, that's SOP, safe operating procedure. Oh my gosh, in an examination, or even though not in examination, you will review every document you have or every performance you have. You have to practice, repeat it again like that. It's normal. Okay. Here, solution, right? So, solution. So, 500 ml. So, 500 ml divided by 1,000. Okay? 500 divided by 1,000. 0.5. Let's substitute 0.5 here. 0.5. Okay? R is 0.08206. Okay? And our temperature is 300. Kelvin. As I said earlier, it will be converted. Okay, so I'll review only. Maybe I missed something. See, it's perfect. I already plugged in everything, and I'll make it slow so that I can detect what is my error. Sarot. May ganon. May ganon talaga. Okay. This is the tendency if you solve too much fast. Okay. You can commit error, and it's normal also. Okay? 24.618 and 2.4. This is only mathematics. That I told you before a while ago. I am not good in mathematics also. Okay, I am very, very honest from the start in my vloggings, in the live streaming, like that. And then I'm also honest to tell everybody, correct me if I am wrong, and then I have to issue an error statement in my vlogging and in my live streaming. Okay? So no worry about that. If you bash me, no problem. Okay, that's part of life. We cannot please everybody. Because normally, why like this? Oh my gosh. See, our number of moles is this one, 0.05. Oh, it's realistic already, right? Because number of moles are always lesser. So I got mistake somewhere in the temperature. Okay, because I solved too fast. I forgot to multiply the 300. See, very simple mistake. Okay, I have 0.05 because our answer also is very suspicious. Suspicious, suspected to be wrong really, and by common sense, why it's very high moles. Moles should not always be greater than 1. Something like that. Remember, moles of A, moles plus B is equal to 1. And the mole fraction also, a mole fraction component A, mole fraction component B is equals to 1. And then why it goes beyond that? There's something wrong, something like that. The better we can detect earlier the error rather than in the final stage. Actually, this is in the final stage, right? Okay. So we have 0.05 mole. Oh my gosh. Pakaloka. So muna ni siya, 0.005. So i-divide na to ni mo siya, the 9 gram. You will divide the 9 gram automatically to the 0.05. Okay? Okay, muna siya may tabo karon. Wow. Okay. Number of moles is 0.05 moles. And we have the 9 gram there in the problem. Divided immediately. Okay. Oh, right. It's perfect. What I mean by perfect, it is one whole 3-digit numbers. That is 180. Okay? So grams per mole is the unit of the molecular weight or the molar mass, right? So 9 grams divided by 0.05. So we have now the molecular weight. This is our answer, really. So we have the molecular weight equal to 180. So we answered already the first question. What is the molecular weight of the solute? Okay? So that is 180 grams per mole. Okay, this is the molecular weight. This is our answer. Okay? This one. This is the answer. Because it states what is the molecular weight of the solute and what compound is this. So what compound is this? That's our problem now. What compound? Because normally it does not discuss in chemistry also. I think it's discussed in the higher chemistry, especially in quantitative chemistry. Of course, if students are very intelligent enough to think, of course they can have this, but for average students, normally they cannot get this because this is a special type of question. What compound is this? Normally it should be given, problem. Meaning it's rare. So what compound is this? Meaning question mark. We have the 180 grams per mole. What compound is this? The shortest or the quickest way to answer this is to look in a handbook. What are those compounds have 180 grams per mole? Or search in the Google Chrome by using your mobile data. You can really get what this compound all about. Okay? But if you learn what is the name for this, we need to solve this by hand. Okay? With mathematical concept combined with chemistry concept also. Okay? Like that. And now, to find out the compound, what will be in our mind? There's a lot. Could it be an inorganic compound or an organic compound? Think of it. And then if you say, in an organic compound, usually those are electrolytes are being discussed there. Okay? The reaction of acids and bases most of the times in inorganic chemistry. Okay? So, it would be safer to consider organic compound. Okay, because in organic compound, it doesn't have the charges and negative charges all the time. Okay, the hydrocarbon law, the hydrocarbon rule. Remember that one, hydrocarbon rule. Okay, for example, if I have methane, ethane, propane, octane, the basis for gasoline is in octane, right? Like that, kerosene, okay, crude oil, that is organic compound. And now we will adopt the rule, R-U-L-E, of the organic, which is for the, let's say, for the singular band. Grabe na nagkaano na, no? Singular band, B-O-N-D, okay? Meaning linear only, okay? So we have the CN, H2N, plus 2. Okay? Like that. And then for the double band, double, like this. We have the CnH2n minus 2. And then we have for the triple band, we have 3 lines. We have the CnH2n na lang siya. Okay? And then the single band is an ANE family or ANI family. That's why we have heptane, methane, that's derived there because that's an ANA family. So if we have methane gas, it belongs to the ANE family. So in a structural formula, that is only abiding the single band during the organic chemical reaction, something like that. And if you have propane also, it ends with ANE, that's belong to the ANA family. Meaning to say, it's only singular band. Meaning to say, it's not double band. Okay, like that. So, if it is now as double band, okay, the CnH2n minus 2, it is now an ENE family. ENE, alkene, butene, like that. So, for example, if you have a butane gas, like that, okay, acetylene, okay, like this. So, that ENE, right, acetylene. ENE is the last. So that means C2H2 from the formula CnH2n minus 2. That's why that is acetylene. Okay, that is a double bond family. I don't need to, to prove, because that is not our coverage. That's a basic concept of organic chemistry. Okay, like that. Because our required here is a compound, we need to identify if it is organic compound or an inorganic compound. Now, there are also compounds that can be discussed in general chemistry and in organic chemistry and in the organic chemistry. For example, the monomers family. You know the monomers? Like that, for example, disaccharides, polysaccharides, the sugars family, right? Then we have the fructose, sucrose, galactose, maltose, okay, like that. Those are sugar family. And take note, sugar family is not electrolyte. That is non-electrolyte. So we have now an idea. This could be, I think this could be a sugar, something like that, okay? Because sugar are not electrolytes. It will produce salts, okay? Like, and this glucose can be glucose, fructose, maltose can be studied also in organic chemistry, can be studied also in organic chemistry, both. Okay? So we need to determine now the formula. Okay? Like this. So if you try to think again, what is this really? Could it be an enzyme, a protein, like this, a hormone? Grabe. Grabe naman yun. Like that, a collagen, something like that. Or let's say an amino acid. But acid is having a negative. Okay? Negative anions. So it's not an acid already. And it's not an alcohol already also. Because alcohol is hydroxide, OH at the end of the chemical formula. So alcohol and acids will be automatically X. Okay? So it could either be carbohydrates, sugars, like that, okay? Or protein, collagen, or an enzyme. Okay? Like that. So we need to. Now, if the clue here is that if the problem will ask the compound, we need to determine the empirical formula. Too much headache. Okay? Now, if you don't know what is the concept of empirical formula, then you will be lost also, because you are usually very, very familiar in the molecular formula, okay, like that. So you are not used with the word empirical formula. Okay, but if you are clever enough during discussion with your instructor, you remember what is an empirical formula, then you can easily solve this one. We can get the compound through that empirical formula, and then we can go to the molecular way. Okay, let's do it now. And then we will not forget algebra also by letting X as the number of atoms. See, even though in chemistry we let X as the number of atoms in order we can have the number of atoms as our coefficient in the compound. Okay, and remember also in the basic concept that number of atoms is equals to the coefficient times the subscript. Okay, like that. Okay, it's always like that forever. Okay, charot. Okay, so now the empirical formula that we try to guess for the compound. So normally it could be the CHO family. CHO or because enzymes are very complicated already, okay, and the protein, because too much, polymerization reaction, so it's no longer applicable here. It will become complicated if we choose the enzyme, the protein, the collagen. No, it's not. The more safest is the CHO, which are the carbohydrates. Okay, carbohydrates, CHO family, composed of carbon, hydrogen, and oxygen. Those are carbohydrate substances. Remember, composed of carbon, hydrogen, and oxygen those are carbohydrates family. Okay? Then, example of those carbohydrates are sugar. So it's safe to say that this compound is really a sugar. Okay? But we don't know, could it be a fructose, a galactose, a maltose, or a lactose? Or the ribose. There's also ribose sugar, R-I-B-O-S-E. Ribose on the word ribosome in biology. Okay, something like that. Okay? Now, the empirical formula of carbohydrates, let's assume lang naman, okay, CH2O. CH2O, my gosh, equals the empirical formula. Charot. Like this. Okay, mention naman siya, di ba? Non-electrolytes ba yan? Kasagaran, most of the compound are not really non-electrolytes. Most of them are electrolytes. Really, because it will react to polyatomic ions, and then it will, combine and click with each other and share the electrons, bond with each other, and then transposing their charges, it will become a compound. But non-electrolyte is not like that. So it's safe to say this is a carbohydrates. Okay? Like this. So CH2 is equal to the empirical formula. Wow. For the carbohydrates. Ganon. Now, for the molecular weight, I can assume, let X as the number of coefficient so that I can get the number of atoms. Okay? Like that. Okay, number of atoms, charot oy, number of atoms, nakakaloka. Number of atoms equals to coefficient. This mathematics already, coefficient times subscript. See? This is mathematical terms, okay? Number of atoms equals to coefficient times the subscript. The coefficient is the number that is beside the compound, or beside the element, that is coefficient. And the subscript is the downside. It's 2, this is a subscript. Okay, and there's also what we know as superscript. The superscript is the exponential. So meaning to say, in chemistry, that would be an ions or a charges. Could it be positive or negative? So those are superscript in equivalent to mathematics. But in chemistry, we will always use the coefficient and the subscript to make it simpler to get the number of atoms. Okay? Like that. Okay, the hydrogen here has a subscript of 2. Right? So we let X as our coefficient. Okay? Like this. So X. Later we'll go back to the empirical formula because we can get that there. Okay. So XCH2O is equals to the molecular weight, which is 180, right? This is our second equation. Wow, may ganon. Our first equation is to empirical formula, and our second equation is in terms of the molecular weight, in which we get the number of molecular weight, which is 180 grams per mole. Now we let X as the coefficient. XCH2O is equals to 180, something like that. Okay? So now, oh my gosh, we go to the empirical formula. Okay? In the empirical formula, basic concept, we need to multiply the subscript, this subscript, and remember, AMU. What is AMU? What is the AMU? That is the atomic number or the atomic mass unit. Hala. Atomic mass unit, AMU, is equal as atomic number in the periodic element. A periodic table, sorry. The element has its own atomic number or the AMU, atomic mass unit. Now we will multiply the AMU or the atomic mass unit or the atomic number to the subscript individually, starting from carbon, hydrogen, and oxygen. Okay, like that. Okay, let's say. Okay, carbon, 12. Okay. We memorize the basic as I told you earlier. 12 AMU for carbon. So 12. Okay. There's no subscript of carbon in the CH2O empirical formula, so that is equal to 1. Okay. So times 1 is equals to 12. Charots. Okay. Hydrogen gas. This is hydrogen gas. This is the H2. Okay. Like that. So our AMU for hydrogen, okay, which is the lightest element in the universe, charot. Okay, 2 times 1.008 because the AMU atomic number is 1.008. So, okay, 1.008 times 2 using the calculator because it involves decimal places. Okay, like this. Oh my gosh, 1.008 times 2 is close to 2.016. Charot. Okay. Oxygen. What is the AMU or atomic mass number or atomic mass unit? Sorry, for the oxygen is 16. Okay, so since there is no subscript here, so equal as 1, automatic, because there's no such zero. Okay, or else it will become a neutral compound or neutral element if you put 0. Okay, like that. So that is 1 or 16 times 1. Obeying only had a subscript times the coefficient, something like that. And we let the coefficient as our atomic mass unit and atomic number, and we solve that individually by taking carbon, hydrogen, oxygen, like that only. Okay, so we have 16. Now you can sum that answer from the carbon, the hydrogen gas, and oxygen. That is what we can know our empirical formula, or components of our empirical formula. So we add that 1, 12, 12 plus 2.016 plus 16. So we have 30. Okay, we have 30. Okay, like this. 30 AMU, or like that, atomic mass unit. Okay, we have now the 30. And now we go back to our molecular weight formula, which is XCH2O is equal to 80, and we let X as our coefficient. Okay, like that. Okay, now in this case, you have equation 1 and equation 2. What do you notice? From equation 2, applying mathematics, the same properties, the same condition, the same situation, the same variable, we can apply ratio and proportion. Okay? Because the first equation has CH2O, the second equation also has CH2O. So there's commonality with two equations, then we can easily cancel that out. So we are using the ratio and proportion in this case. So when we speak of ratio and proportion, that is involving the division operation of mathematics. Okay, let's do the ratio and proportion. Okay, my gosh. Actually, this is not discussed in the problem solving like this. Kuha ako kakuha. Charot! Okay. Like this. So we have now XCHO, which is the molecular weight, is equals to 180, like this. See? As our numerator, and divide that with the empirical formula CH2O. CH2O, which is equals to 30. Nakuha naman na to siya, di ba? Oh. So, muna na siya ang ratio. Cancels it out SH2. Our X will be equal to 6. And this is not yet the answer. X. So, meaning to say, this X is in the beside the compound. This is the coefficient. That is not yet the number of atoms. Remember, that is still the coefficient that we let X to solve for. That is not yet the atom, because the atom is equal to the coefficient times the number of moles. Okay, so now we have the coefficient equals to 6. Okay, now individually we can get the number of atoms again, just like what we did in empirical formula. We also did this in the molecular weights. Start with carbon. Okay, carbon, so coefficient, which is X, okay, 6, okay, like this, times the subscript. What is the subscript of the molecular weight? Is still 1. So, times 1 is equals to 6. So, we have 6 atoms of carbon. Again, X times the coefficient and the subscript. Our coefficient is 6 and our subscript is 1. So, we have the number of atoms of carbon is 6. Okay? Like that. And then for the hydrogen gas, okay, X still beside with the hydrogen gas. So 6 coefficient times the subscript 2. So it equals to 12. Okay. Oxygen, still X is beside. Okay. So X times the subscript. So X 6 times, and there's no subscript. It's only 1 automatically. So we have 6 times 1. Okay. We have 6 atoms of carbon, 12 atoms of hydrogen gas, and 6 atoms of oxygen. Now substitute that there in the CHO. Okay? CHO. Carbon 6, H12O6. And our compound is carbon 6, H12O6, or 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen. This is glucose. Okay? This is the formula of glucose, which has a molecular weight of 180 grams per mole. Okay? Actually, this problem is difficult. Okay? So 180 grams per mole is the glucose. So we found now what compound is that. That's a molecular weight of 180. So that is glucose. This is the sugar from our blood. Glucose. And we need to regulate the glucose in our blood so that it will not become higher, so that we will not be undergoing the diabetes or the type 2 diabetes or the diabetes mellitus because of too much glucose level in your blood, because glucose is the sugar of our blood. So this is the sugar in our blood, the C6H12O6 inside your body. Malum? The C6H12O6 is you bring that every time when you sleep, when you go to work, everything. And without this, you will die. Okay? Without glucose, all people will die. Malum? Okay, because of the percentage body mass composed of CHO and other salts. Okay, so that's still chemistry. So meaning to say, without science we will die. Without chemistry we will die. Okay, so that's interest most about the subject called chemistry under the pure science. Okay, thank you so much for listening for this, colligative property discussion. Okay, it takes a longer time because the problem also requires, thorough problem solving, and I got mistake somewhere in the substitution only like this, and you have to be careful, okay, do it systematically. So the compound is glucose pala siya. Okay, then if you found another CHO, for example, if you found C6H8O6, so that is, what is that? Charot. That is ascorbic acid. Okay, and you are wondering why acid? There's no negative there. No, actually there's CHO raised to the power -1. Actually the ascorbate is C6H7O6. Then if you add that with the H ion positive and the negative of the ascorbate, it will clip into one compound as an organic compound, and it will become CHO. Though it is in CHO form, that is an organic acid, weak organic acid, and that is vitamin C. Without that acid, we will not also live. We will die. So meaning to say, this C6H8O6 also are inside our system every day. So without the C6H8O6, which is ascorbic acid or the vitamin C, and without this glucose C6H8O6 as our blood sugar, we will die. Okay, so how important this problem solving pala siya. Okay, and we know that through explanation. Okay, like that. Because it will be obtained from the food we eat. Okay, basically from the plants to the food cycle, like that, and it will convert into chemicals, and it go to our system, digestive system, blah blah blah, so and so, and go to our digestive chemical reaction. There is a natural digestive chemical reaction inside our body that produces also HCl, like that. Okay, instead, don't think that HCl is only for the muriatic acid or for the cleaning of the bowel or cleaning for the test to make it stain. We have also HCl in our body. Okay, but the thing is, our HCl is more dilute or diluted HCl, but it's still a form of HCl. Okay, like that. So these three, HCl, ascorbic acid, and glucose, are present in our body. Okay, and also the citric acid. Okay, what is the formula of citric acid? C6, charot, ganon, H8O7. Okay, so ang oxygen ray diferensya niya. Okay, but the ions are -3 for the H ions for the reacting to the citrate, C-I-T-R-A-T-E. Okay, this citrate, ascorbate, phosphate, sulfate, manganate, chromate, like that, oxalate, like that, chlorides, like that, carbonate, blah blah blah, chubachucho, acetate, supersulfate, thiosulfate, those are polyatomic ions. Okay? Negative charges react with the positive charges, and most of the time these positive charges are the acid, the hydronium ion or the H+, or it could be, my gosh, it could be a group 1 and group 2 in the periodic table. Okay? Thank you so much for listening. If you like this live streaming,